Well, hi and welcome to my shop. Thanks for joining me. And I got something a little bit different to work on. I've got this guy. There's his tubes. Guitar amp. Oh, guitar amp. That looks like asbestos along the bottom there. Yeah, for sure. Okay, so this is all I have though. I don't have the cabinet. I just have this piece. And the owner's instructions are make it work like new. But he's done something really nice. He's actually included a schematic. Very simple, very simple. One tube in the power supply for a rectifier. 12AX7, that's really two tubes in one for two-stage audio amplification. And then 50C5 to punch the power out to the speaker. Quite a simple arrangement. I see the filaments are in series, which is what you would expect. 35 W4, 50 C5, so that's 85 plus a 12, 85. That's 95, that's 97, it's just under 100, so there's probably a resistor. Yeah, there it is there. There's a resistor in the circuit to get rid of the rest of the pressure. Cut the pressure back a little bit. Fuse and a switch. Probably a unpolarized plug. Ooh, unpolarized plug. Ooh, one side of the line is grounded right onto the case. That's what it looks like. Boy, that's not too good. We'll investigate that a bit. Just see if this guy's a shock hazard or not. Yikes, it really looks like it, doesn't it? How in heaven's name can they do that? Just put a ground on there. Well, we'll investigate that a little bit. So there we are, two inputs for two guitars. And of course I don't have the case, I don't have the speaker. Speaker, oh no, speaker, wait a minute. Wait a minute, I don't have the speaker. There's the output transformer. Let me not make a mistake with this one. So the output transformer is mounted inside here, and it's just a regular speaker. So I won't end up doing what I did last time. Let's see if we got a fuse in here. Come on out. Hey, the fuse refuses to come out here. Can it do that? There we go. Looks okay. But looks can be deceiving. Oh, how do you like that? Fuse is blown. No, fuse is good. Fuse is good. So let's put a little speaker on them. You can just twist these wires up here. This is certainly a little simpler than having a whole radio to work on. It's just the amplifier part, and this is a fairly simple. As many guitar amplifiers are very simple. It even gets simpler than this. Some of them are just one tube amplifiers. Okay, so that's not the best, but that'll do. That'll hold on. Need some kind of input into there. I'm not going to bring my guitar in, that's for sure. So let's see, we can use my audio signal generator. Why don't we try that? Now the audio signal generator I have can put out a very high signal, very powerful or loud signal, and you don't want that going into the guitar input because that's built for something pretty quiet. Ooh, did you see that? We got to check the ground before we make it. Now, by the way, I was operating my shop on an isolation transformer, and I have stopped recently. I removed it. So, and I plugged this guy in. He's plugged into the power system like anything. I mean, I have a current restriction light bulb in the circuit, but that doesn't change the grounding and that kind of stuff. And I've done that for a couple of reasons. The main one is, and I know I'm going to get a pile of arguments over this, I think I'm safer and better off. Working the way I've worked my entire life with just a regular grounded outlet. I've got the isolation transformer. I can use it when I need or want to. But I think as a regular piece of equipment, I think I'm making a little bit of a mistake using it. Now, okay, everybody, start writing the comments. So, I'll give you a better example. With this guitar amp, if there's an electrocution hazard, I got to discover it. And the easiest way is plug it in the way anybody would plug it in and start poking around for voltages. Which is exactly what we're going to do right now. And find out if this guy can be a killer. I mean, lots of musicians used to get shocks years ago, say when I was in high school back in the 70s, because of a lack of full understanding of all this stuff, and all this equipment had unpolarized plugs and everything you can think of. And I think most musicians were quite concerned about getting a shock. So, okay, so we got this dialed up here. Let's plug them in. Plug them into my current restricted outlet here. Plug it straight into the wall, making sure my speaker wires don't short out on something. Just a quick inspection underneath again. Resistor not burned. No exploded capacitors. Everything looks original in here. This isn't the oldest thing in the world. Yeah, everything looks good. Resistors look good. Doesn't mean they're good. It just means nothing obvious is wrong. I have not tested the tubes or anything. My understanding is this works. It doesn't work well. That's what I believe is the situation. So let's find out where the on-off switch is too. There's the on-off switch. And I'm going to guess it's, I don't have to guess. I have the, yeah, the one looks like a tone control. Volume is on the tone control. The on-off switch is on the tone control. That's the tone control. This is the volume. Volume's down. I think we're set here to turn it on. Okay, so we're going on with power restriction. Only the smaller bulb, so high restriction. So watch this bulb when I switch it on here. I didn't see a thing in that bulb, eh? But I did see the indicator light come on. Funny, I would have expected a bit of a flash there, you know, as this big capacitor charges up. Maybe this capacitor is not too much good anymore. And what do we hear coming out of the speaker? You don't hear a single thing. Nothing whatsoever. Okay, hold it for it. Hold it for it. Okay, on the basis that last time I did something wrong here. Let's just double check. It's definitely the output transformer. Definitely the output from it. No question about that. Now, let's turn it back on. I'm going to give the tubes a bit of time. Okay, one of them's lighting, so if one light, yeah, they're all lighting. Maybe I didn't give it enough time because I've got it on current restriction. It takes a while to get going. And the exciting thing is absolutely nothing coming out of it. Okay, so let's check for dangerous voltages now. We're on the AC scale. This is to my house ground. Ooh-wee! You can't see that, can you? You missed the exciting moment, but I'll show it to you again. So the question is, will this guitar amplifier kill the guitar player? And the answer is, ooh, maybe. Maybe, maybe, maybe. Turn it around. And we will repeat the test. Here, pick off a brown spot. And now we see nothing. So wow, I think this qualifies as a killer. A killer. It's a killer, man. But it's safe now the way I have it plugged in. But for sure, when I had to plug in the other way, you're definitely on your way to getting a shock or burning something up. It's really, really dangerous. These old, I don't understand how they got away with this. Must be some part of the story I'm missing, because I certainly lived through this era where everything was non-polarized, two-prong plugs. And outlets were not polarized or anything, so you could plug everything in this way or that way. Most of the time, a thing like a radio, all the metal parts were kept inside the cabinet, the knobs cover the shaft coming out. There's no metal to touch. Maybe the screws on the bottom. If you pick the radio up, maybe you would touch the screws on the bottom. Maybe then you could touch the chassis. Or perhaps on the antenna, but even in some radios, the antenna is contained inside the back. There's nothing for you to touch. And, can you smell that? I don't have smell-o-vision, so. That's the smell of something that hasn't been turned on for a long time. There's a lot of heat coming up from this resistor. The most sensitive spot on your body, at least spot you'd want to use publicly, from what I understand, is your upper lip. I guess that makes some sense, because that's the last chance you have to find out how hot something is before you stick it in your mouth. But your upper lip is very sensitive to heat. So as I was putting my face over top of this, I can actually feel it with my upper lip and most of my face too. So you see, I'm more than a pretty face. Now, what are we going to do next? Well, we got to figure out how come this thing's not producing any output. The tubes are all lighting. Blown output tube is probably a very high likelihood. I think we better test the tubes at this point. That's probably the best thing to do. So let's do that. Okay, so I've got my good old tube tester out here. Here he is. Resting nicely in my office, or my shop chair. So we have a Thorcraft 12AX7 made in Canada. Thorcraft. 12AX7. Let's dial up a 12AX7 here. Problem with these roll charts is you never know which side of the roll chart a tube is going to be on. Sometimes you have to roll back and forth quite a few times. Hey, what's going on here? This side ends at 8. Oh, I never noticed that about this roll chart. The listing is backwards on the left-hand side. Let me just get a little more of this on camera. We got a camera with a mind of its own here. Yes, numerous camera changes I won't go into have resulted in me having to relearn all this again here. Maybe if maybe, just put that back a little bit. Sorry about the camera work here. There, that's a little better. Now I think we're all set. So we'll find 12AX7, 12AX4, 12AX7, 6.3. Filament voltage is set properly. Signal 2, 18 low. PGK77, PGK77, 3516, 3516, 47 on the sensitivity. F for the plate. Oh, all kinds of instructions here. P1G1K1 and P2G2K2 twin diode. So there's actually 2 tests, and we throw some switches between tests. And we're all set to plug them in. Whoa, did you see that thing go? Wow. That really, really took the current there at first. It's probably hot now. So let's do the shorts test. No shorts, I don't think you can see the dial, but GM test, very good. That was excellent. There's nothing wrong with this tube. This tube is in great shape. It's really working good. It's like a fairly new tube. So, next most likely character is the output tube. 50C5. 50C5. Yeah, went right past it here. 50, there we are. 50C5. It's also a 2-part tube. And of course, oh wait a minute, it's 50C6. Ooh, 50C5. It's not a 2-part tube. I didn't think it was actually, even though I said that. Filament is set to 47. Got to remember to turn that back after, or else I'm going to potentially cook another tube up. Signal 4. Bias 12 high. 1576G. 1576G. 4300. Okay. 32 on the sensitivity. C for the plate voltage. PE, G1, and G2. So it looks like we do 2 tests, a G1 test and then a G2 test. I don't know what PE means. PE, what's that? PE. What is PE? PE, PE. Pentode section of tube being tested. Not that that concerns me too much. So we're ready to plug it in. Definitely on 47. While that's warming up, let's double check everything here. 50C5, 47, 4, 12H, 1576G, 1576G, 4300, 4300. 32 on the meter, and we're good to go. C on the plate, and that's it. We're ready. Check for shorts. Nothing. test. Oh, this is a, yeah, test good. And then G2, test good. So, very good. In fact, this tube's really good. So, how come we got no output from this amp? No sound in the speaker at all. That's the same speaker I was driving the plate current through from the last radio I was fixing. We better check that speaker. But let's check the last tube before we do that. The last tube is the rectifier tube, 35W4. I think it's lighting up. It's working, I think. 35W4. I don't think this. So 35, of course, on the filament. The signal. It's a rectifier. There's no signal issue. No bias setting. 00763. 00763. 0100. Sensitivity 25. And the last thing is E. E for where the plate goes. Put that back up there too. And we're set to check this tube. 35. It's definitely got the rate. There we go. It's a very, very cold day here in Toronto, and it's going to be even colder tomorrow. It's way below normal temperatures. So, okay, we'll check for shorts. I suppose if there was a short in this thing, we would have known the moment we turned on that amplifier. And we're testing the rectifier. Look at it. Okay, you can't see it, but this meter is not moving one bit. So we've got a blown 35W4. I say, because do I have one here? Blowed 35W4. Let's see what we can find here. What's this? That would be a 35W4 2 seconds later. Okay, let's put it in. Make sure it's a 35W4. 35W4. How do you manage to just pick that rate up like that? Whoa! Whoa! What was going on with that? I don't know if you can read it there because it's not going to be in focus on the camera. 35W4, clear as a bell. Wow, this can't be good. Let's check it out. Let's go again. Now it's normal. What was that? Did I see that right? That is really mysterious. Well, I don't know what to say about it. Other than, I saw it glow like crazy. Am I nuts? You know, it's a great thing I got this on video because stuff like this I can always, if I really want to, I can go back and look at it again. So. Anyway, on with the test here. Maybe there's a short in it. If there was, maybe it burned it out. I don't see anything happening. It's glowing along pretty bright. Wow, it tests just fine. Turn down the filament voltage because most tubes are 6-volt tubes, right? So chances are, if you don't turn the voltage down, you pop in a 6-volt tube without thinking. Of course, I would never do that. So we'll put in the good rectifier. Turn the power off to it first. That'd be a smart move. Okay. Where's my marker? I gotta put a big X on here. So just bend one pin. That's my personal, oh, they're over here still. My personal technique is I bend down a pin on a bad tube, so I can't make a mistake. Stop looking down there because the action's up here again. Boy, it'd be great, you know, if I could have a remote controlled camera. Of course, I don't know who would be controlling it because it's just me here. Draper, yeah, Draper, a cat-controlled radio. Man, I really got to look into doing this. Some form of cat control. Did I say radio? Cat control on my camera. That would be great. So, should we give this thing a go? I think we should, because I got other things to get onto here. Speaker's wired up. Switch is on. Oh, I had the switch off. I had the main switch off my power. Now, this time, I think we'll see a different result on this light bulb. So, putting it on with current restriction. Here we go. Indicator light has come on. Light bulb's doing nothing over there. Nothing at all. Nothing at all. Oh, there it goes. So now we know we got plate current flowing quite a bit, really, I think. Maybe too much. Maybe too much plate current there. Okay. I think I'll leave it on restriction for now. Yeah, hey, humless, hum-free. Let's see if it's producing an output. Oh, wait. Did I unplug and plug that back in? I have to be ever mindful about this. We're in the clear. We're in the clear. What exactly is the problem? The problem was the blown rectifier? Because this is a nice amp. It's nice and there's nothing funny going on. No hum, no hiss. Wow. Maybe I will have to plug my guitar into this. So I think what we'll do is we're going to check the voltages underneath here, check the grid voltages, things like that, make sure we're not burning up any of these tubes. And, but boy, it doesn't seem to have any problem at all other than the blown rectifier tube. Well, we'll check it out. So, thanks for watching so far, and we'll see you on the next one.